All right, everybody, today we are moving on to lesson 3.3, and this is solving systems of linear equations by elimination. So with our warm-up, using what we know so far, I think we're going to start by solving this using substitution. And so we would add 3y to the other side to get that x equals negative 15 plus 3y. Now that I know what x is equal to, I can take it and I can substitute it in my second equation for x. So it would look like this. 5 times negative 15 plus 3y equals negative 3. And then we would distribute. Combine like terms. We could also add 75 to get 18y equals 72. Divide by 18 to get y equals 4. Take the 4, substitute it in for y over here to get x alone. Got a full process here. Just pick a different color. So we have x equals negative 15 plus 3 times 4, which would give us 12. Negative 15 plus 12 would be negative 3. Our answer would be negative 3, 4. So as we can see, that takes a lot of space. That's a lot of work, a lot of things you got to keep track of. So today we're going to learn elimination. It's actually going to make things a bit easier. So when I have elimination, I have to make sure that I have my variables lined up. So I have my x over my x, my y over my y. I'm going to add them together. I'm going to make like one big addition problem and add these problems together. And the reason I'm doing that is because I can see that my negative 3y and my positive 3y are opposites. So when I add them together, they are going to equal to 0. So watch this. X plus 5x makes 6x. Negative 3y plus 3y equals 0. Negative 15 plus negative 3 would be negative 18. So now I have negative 6x plus 0 equals negative 18. We know that I don't have to write plus 0 in anything, right? Because it's not going to actually help me solve. It's not really necessary. So I can just divide by 6 to get x equals negative 3. So this is elimination. Makes things much easier when we can cancel out one of our variables. From there, I take my x, I put it back in. Let's put it in our original equation. Negative 3 can go in right there. We have negative 3 minus 3y equals negative 15. We can add the 3. Negative 3y equals negative 12. Divide by negative 3. Y equals 4. Our answer is negative 3, 4. So using elimination makes this process much quicker. Let's take another look over here. I have negative 5x minus 5y equals 25 and 5x minus y equals 17. I can add these together because I see that my x values are complete opposites, so they are going to cancel out. So let's go ahead and let's add them together. Negative 5x plus 5x equals 0. Negative 5y plus negative y is negative 6y. 25 plus 17 is going to give us 42. Divide by negative 6. And y equals negative 7. Take the negative 7, substitute it in one of your equations. We can use the top one. This gives us negative 5x minus 5 times negative 7 equal to 25. 5 times 7 is 35. Subtract 35. Negative 5x equals negative 10. Divide by negative 5, and x equals 2. Final answer, 2, negative 7. Okay, got another one here. I have 3y plus 2x equals 17, and then I also have 3x plus 4y equals 24. You can't see what's wrong here is my y is not lined up with my y. My x is not lined up with my x, and I do not have opposites. I don't have a positive and a negative. So let's start by lining them up. So now we do have our x with x and our y with y. Okay, but again, I do not have opposites. When I add these together, nothing's going to cancel out, right? I'm just going to get 7y plus 5x, and that leads me no closer. So what I'm going to do is I'm going to multiply one of the equations, or in this case, I guess I'm going to have to multiply both of the equations so that I do have opposites. So let's pick a variable. I think it's going to be easier. It's going to keep things a little bit smaller if I'm going to make my x values opposites. So I'm thinking about the LCM of 2 and 3. What's the smallest number they both multiply into? It's going to be 6, right? So if I multiply this top equation by 3, I'm going to get 9y plus 6x is equal to 51. So to make these opposites, I'm not just going to multiply this bottom equation by 2, I'm going to multiply it by negative 2. So that my x is negative and will cancel out. So I'll have negative 8y minus 6x equals negative 48. So notice for both, I multiplied everything in those equations, right? Every single piece got multiplied. Now I can add and eliminate. 9y plus negative 8y is just y. Our 6x canceled. That's what we wanted to happen. 51 plus negative 48 is going to be 3. So y equals 3. Let's plug that into the top equation. We'll say that 3 times 3 plus 2x equals 17. We get 9 plus 2x equals 17, and 2x equals 8. X equals 4. Final answer, 4, 3. Okay, I have a fraction for my second problem. So for this one, I'm going to multiply it to clear out my fraction. I also see that none of my values are opposites, so I'm going to multiply it by a negative number to make them opposites. So this is going to give me negative x minus y equals negative 8. And then let's take our top equation and rewrite it underneath so that our x and y's are lined up and that we can eliminate. So the x comes first, plus 3y equals 17. Now when we add, the x's cancel, and I get 2y equals 9. So when I divide, I get that y equals 9 over 2. Okay. Let's put this in our equation. Let's put it in the top equation. It's going to be a little bit easier to put it in there to solve for x. So 3 times 9 over 2 plus x equals 17. We're going to get 27 over 2, which unfortunately I can't simplify. So I'm going to have to multiply this as well by something to get rid of my fraction. So I'll get 27 plus 2x equals 34. and I continue solving. So I get 2x equals 7, and then x equals 7 over 2. So I have two fractions, but it's okay. We've been working with fractions all year, so we know how to work with them. Final answer is going to be 7 over 2, 9 over 2. X comma y. Just put them back together. And that is it for solving by elimination. Make sure you're always writing your points x, y. Look for opposites in one variable. If you don't have them, you're going to have to multiply one or sometimes both equations. We didn't have any word problems today, so that didn't matter.